All right, lesson 3.6. Today we can identify the amplitude, period, frequency, phase shift, and vertical shift, the midline of a sinusoidal function. We did this last time, but today specifically we're going to look at it from a transformation perspective. So that's what I'm going to put today, from a transformation perspective. So if you learn the math on lesson 3.5, I'm sorry, on 3.5, you'll actually know all the math. And today will be more of like applying vocabulary to the math. Now, if you did not learn the math in 3.5, hopefully today you learn the math. And so you're caught up. So let's begin here. As a review, I have the equations up top for a sinusoidal functions. They follow this general equation. I put general here. I should have said it's a standard form. I'll show you general later. This is the standard form. Standard form of the equation is this way. For the standard form of the equations, here they are. And these two for sinusoidal functions. Now, A, remember that's the amplitude. From the B, we can find the period and frequency. The C value is the phase shift. D is the midline. Today, you're going to hear me say we're solving for the argument. What I'm talking about, the argument, is the inside portion, the bx minus c. That's what we're going to call the argument. And as a reminder, as we've kind of done the bell ringer, sine function, it says begins in quotes at the origin. Because why did I put it in quotes? Does sine actually begin, like literally start at the origin? Is that actually where it starts? No. No, it goes to the left, but I just put begins in quotes so that if you're graphing, you just think that's kind of our first point to graph. That would be the sine function. So does sine literally begin there? No. No, that's why I put begins in quotes. I could just say the y-intercept of sine is at its midline, but I'll leave it as it is. And the cosine, it begins at its maximum, meaning the y-intercept would be the maximum cosine without transformation. That's why it says parent function. Parent function means no transformations. So that's sine. And as a reminder, cosine, its y-intercept is at its maximum if it's a parent function. So on. Okay. So you can look back at this if you need help with your vocabulary. One more thing on midline. I put midline equals D. Truthfully, you're going to need to write that as y equals. It's an equation y equals. So make sure you make note of that. You won't ever just put the D value. It'll be y equals D. All right. So make sure you draw attention to that on your notes. Let's start with example 1 here. It says the graph of y equals a sine bx plus c is a horizontal shift of the graph y equals a sine bx. Notice the difference between these. What's the difference between these two equations? Bracket. There is a bracket, but that doesn't mathematically do anything. This has a minus c, which means this has a horizontal shift. That's the only thing. The c generates the horizontal shift of the graph. The starting point in the circle is shifted from 0, 0 to c comma 0. And remember, if you remember last class, we did not do phase shift for just about the whole lesson. And there's a note here, and I'm going to draw attention to this when we get to example 2. Okay, so what we're going to do is solve for one cycle by solving the argument equal to the parent function's period of 2 pi. So let's get here and fill these out, and we're going to see how this graph looks. On this problem, what is the amplitude?
It looks like 3.
It's 3. The amplitude is 3. It comes from right there. The amplitude is 3 here. Remember, it's always the positive a value. That's where you get your amplitude. Okay, period. Do you remember the formula for period? 2 pi over b. So this time it's going to be 2 pi divided by
1.
Now, what's the b in this case?
3. Oh, wait.
3. So this 3 comes here. So I'm drawing arrows so you can see where the values are coming from. Okay, the phase shift. Now, where's the phase shift?
C.
That's the c value. And because it's in the inside, it's a... That's right. And by the way, notice this says to multiply by 3. Did we actually multiply 2 pi by 3? No, it got divided. That's built into the formula to take away that line. But this one, the phase shift will be pi over 6. Which direction? Left or right? Pi over 6. To the right. Because inside's a liar, it'll be right pi over 6 units. And finally, the midline. What's the midline if you have no value on the outside?
0.
0. So midline, you need to put y equals 0. So I'll go ahead and I'll put this on the graph. Here's, if you have a straight edge, your ID badge or something, you can go ahead and draw the midline, y equals 0. So sine usually, quote, begins at 0, 0. Sine function begins at 0, 0. This will not begin at 0, 0. Where will it begin? Pi over 6, comma, 0. So put the first point, pi over 6, comma, 0. That's going to be our shift right there. Pi over 6, comma, 0. Okay, now a period is normally 2 pi. This period is going to be 2 pi over 3. Alexis. Come on. So it's normally 2 pi. This one's 2 pi over 3. What does that mean? This is not going to take 2 whole pi to repeat. It's going to repeat quicker. So if you want to think about where is 2 pi over 3, I'm going to add this real quick to find out where one full cycle is. I'm going to show you exactly here in a second how we figure out where all the points go. But here's what I want to do. Take 2 pi over 3. And I'm going to add pi over 6. I'm going to figure out where do I complete one full cycle.
Would you multiply the 2 pi over 3 by 2 to match the base of the 3?
Yeah, that's called what from, I don't know, middle school somewhere. What do we call that? When we multiply top and bottom. It's really multiplying by 1. It's just a funny looking one. It's 2 divided by 2. I'm not going to cancel my 2's here because this is called finding a, starts with the C.
Constant.
And it rhymes with on in denominator. It's a common denominator. Yeah, we got to find a common denominator. So I multiply top and bottom by 2 over 2, which means I'm working with 4 pi over 6 plus pi over 6. What do you get when you have 4 pi over 6 plus pi over 6? 5 pi over 6. Okay, that's where we're going to complete one full period. So at 5 pi over 6, come over here, put another dot. There you go, 5 pi over 6. Now there has to be 3 key values in between these, evenly spaced. What's nice is you can look on your chart and you see how many little dashes do we have in between. 3. So I'm going to have 3 points for sine that fall in between those 2 zeros. I'm going to have, since it's positive, its maximum. So if you go pi over 3 to the right, go up to its maximum. What was its maximum or its amplitude? 3. So go up 3, go over 1, right? Go up 3. This is the value pi over 3, comma 3. So it'll go to its maximum. After it hits its maximum, where does sine then go? Not to the minimum yet. It returns first to the 0, the midline. Very good. So that's pi over 2, comma 0. And then, so it goes from 0, maximum, 0. Now where? Minimum, which would be -3, and then on. So this is 2 pi over 3, comma -3. Now that I found the points, we could predict where the others are. I'll change colors one more time here. So I go 0, maximum, 0, minimum, 0. What comes next? Maximum. I'm not going to label these points. I'm just going to plot them. Maximum again, and then following 0, and the next one, minimum, and finally, as you head off the page, you'll have another 0 over here somewhere. And going to the left, let's go left now. So minimum, 0, maximum, 0, minimum, 0, maximum, 0. What would be here? A minimum, and over here, 0. Let's connect those points.
Oh, I said curve it or?
Yeah, curve it. Sine and cosines are always waves, so we should curve it as best we can. Try not to straight line it. There we go. Now, in case you're working on a graph where the lines aren't so nice for us, where that one we had 3 lines for the 3 points. So it's really easy. It's like, okay, for every, I say 3 lines, I'm sorry. They call these tick marks. I had 3 tick marks, 3 boxes in between the in the one period. I had 3 open boxes, 1, 2, 3. And so we knew, okay, maximum 0, minimum, perfect, fit perfect. Well, if you don't, what you do is you take your 2 pi over 3 and you divide by 4. If you divide that by 4, that will tell you how far the space each point. So for spacing purposes, this is extra. All this is free. Okay, I'm gonna just give you this for free here, but it's extra. If you take your period and divide it by 4, which means it's right now 2 pi divided by 3. If I divide that by 4, let me write it this way. You now divide that by 4. That'll tell you how far to space everything apart. So 2 pi divided by 3 divided by 4. Dividing by 3, then dividing by 4 is the same thing as dividing by 12. And that could reduce to tell you every pi over 6 you have a new value. Go back to your chart. How much is in distance? How much x distance is 1 box here? Pi over 6. So that would be telling you to space every pi over 6. Every block you attain a new key point. So these are for finding key points. Let me put that there. Finding the key values. Finding key values or key points, I could say. You had a question, what's up? Yeah, go ahead. So that's how far apart they are. Finding the spacing of the key points. Should say finding spacing of key points.
Where'd you get the 4 from?
Because I know it's gonna sound weird that there are 4 key values or 5 key values: 0, maximum, 0, minimum, 0. But this one's actually a repeat of the start. So you would actually count it as 4 unique key points when you do the math. Because ultimately this one is a repeat of this one from the cycle. You know what I'm saying? How that one starts the new cycle. So because there was 4, that's why I divided by 4. And it would be the same for cosine. All right, let's roll this up and let's do another. How about this one? Okay, whoops. Walk me through. What's our amplitude on this problem?
2.
Good. Now, what if it said -2? Still be 2. Perfect. Okay. What's the period? Well, it's 2 pi divided by. Well, that's tricky when you divide by a fraction. What we could do is say, is this inside portion a liar or truth teller?
Truth teller.
It's on the inside. It's a liar, which means you don't do what it says, you do it's lying. Instead of multiplying by 1, dividing by 2, we can divide by 2. Excuse me. Instead of multiplying by 1, dividing by 2, we can multiply by 2, divide by 1. That's how when you have a fraction, or excuse me, a value being divided by a fraction, when the fraction itself is doing dividing, you can multiply by its reciprocal. So what's 2 pi times 2 over 1?
4 pi.
4 pi. That's our period here. Now the phase shift, remember the inside's a liar. So we're going to go left 2 pi units. And finally, the midline. What's our midline going to be?
-1. Y equals -1.
Y equals -1. Good. So come up to your graph. Let's add that midline at -1 across. That's +1.
Yeah.
Goodness gracious. Let's go to -1 with that. That's y equals -1. I wrote 1. Sorry. -1. There we go. Finally. Cosine. Does cosine, quote, start at its minimum or maximum or 0? Starts at its maximum. Anthony, stay with me, please. The maximum on this one is 2 units up from the midline, which means its maximum will be at +1. Now, that's where it should start at. Now, do we actually start there?
No.
How far is that shifted?
I left 2 pi units to go all.
right there. That's where we're going to start our graph from on this problem. We're going to begin from negative 2 pi, comma, 1. Now, how long will it take for this cosine function to repeat its values?
Approximately 4 pi.
4 pi units from this spot. So what's negative 2 pi plus 4 pi?
Wait.
Okay, so once we get here, we will have completed a period. So that's how long it'll take. So one of the ways I did it earlier is I had 3 boxes and I just said, okay, that's maximum, minimum, 0, whatever. Another way you can look at it is this. Yeah, on cosine, these are the maximums. What should happen in the very middle of the 2 maximums?
Minimum.
The minimum. So this is left 2 pi, this is right 2 pi. What's the very middle? 0. The minimum will occur at 0 on the x. And if these are 2 units up from the midline, the minimum will be 2 units down. So you can go here and say that's going to be my minimum. Now, what's going to happen halfway between the maximum and the minimum? A 0. So we could come in here and say, okay, well, where's the 0? This is another way of doing what I just did. What's in between negative 2 pi and 0? Negative pi. So at that point, we should have our 0. I'm showing you different ideas of how, that's not going to be a 0 though. What's our, instead of 0, the midline is negative 1. There we go. And the same over here. Between this minimum and this maximum has what would normally be a 0. In this case, it's not a 0, it's a midline. What's the value in between 0 and 2 pi? All right, so we put that there. At pi, we have the point negative 1. Okay, now if we connect our dots, we should get these values. Okay. So again, make it like a wave. Don't make it like a line. Make it like a wave to be more accurate. We could do hand trick to try to get more in between. I'm not going to worry about that. But so I want to just kind of round these out a little bit. Kind of like that. I missed one, but and that will be our function. Now, what I haven't started doing is throwing in the transformations, but in a moment we'll start writing these in. This graph was shifted. What's the name for shifted? Translation. It was translated 2 different directions. We had a phase shift. That's a horizontal translation, left 2 pi units. We had a vertical translation, down 1 unit. Okay, cosine did those 2 things. We had a vertical dilation. Vertical dilate means to multiply. We vertically multiplied the graph by 2. And look at the horizontal. Did I horizontally multiply by 1/2? No, what did we actually do? We multiplied by the reciprocal, which would be 2 over 1. Multiplied by 2. We had a horizontal dilation of 2 as well. For delta map, is this graph moving faster or slower?
Slower.
Slower. It's actually moving slower because the period became 4, 5. If you increase your time period, you decrease the speed. All right. With that, I believe oh no, I have a part C. I'm sorry. Let's roll through this one more time before I give you your first. All right, in this problem, what is our amplitude on part C here? 3. What is our period? Well, let me ask this. What's our B? I probably should be writing these so later on we can figure out where the values are coming from. The B is 2/3. The formula is you take 2 pi and you divide it by B. What's the same thing as taking 2 pi and dividing it by 2/3?
2 pi multiplied by 3 times.
So it's 2 pi times 3 over 2. That's correct. I'm going to slide this over so I have room to fit this in. And so let's do a little quick math here. If I'm going to multiply by 2 times pi and then multiply by 3, but what's 2 pi times 3?
6.
Then you divide that by 2. We should get 3 pi there. Okay. Phase shift.
There is no fish.
Great. Why is it none?
There's no parentheses, there's no C.
There's no parentheses, no C value. So over here, you can put C equals 0. It's not there. By the way, if they don't give you a parenthesis, the parenthesis begins immediately after the trig function. So where it says sine, as soon as it starts, I know it looks like sin, but as soon as you have that in, you put the parenthesis there. And if there is no parenthesis, it goes immediately after the x. Like that. That's how you do trig functions. Anthony. Come on, man. Sit up. And now midline. What's our midline on this equation? Because our d value is 1. All right, here we go again. At 1, this time I'm going to get it right. At y equals 1, we have our midline. Okay, where does sine normally begin at? Sine normally begins at the origin. Do I shift it left to right this time?
No.
No. Okay, so instead of the, how about this to maybe more mathematically accurate? This time I'm going to say sine begins at its midline, or has the y-intercept at the midline. I'm not shifting left to right, so that's the accurate point right there. That point would be 0, 1. Okay, we had a period that is 3 pi away, so go 3 pi away and put that point. 3 pi, 1. There's where the second cycle would begin. Now, in between, what's going to happen? We're going to have a maximum, a minimum, or a maximum, then a 0, then a minimum, and then back to the 0. They need to be evenly spaced. So what I did the very first problem is I basically looked at it, and on that problem, we only had 3 boxes in between. How many lines do I have to work with here this time? 5. So they need to be evenly spaced in here, which is a little tricky. I also, on the first one, after we did the problem, I showed you the math, which means you take your period and divide it by how much? Do you remember?
4.
Divided by 4. So you could say, okay, it's 3 pi divided by 4. The other thing I did is I looked at and I said on problem number 2, as I said, okay, what's the halfway point between 0 and 3 pi? What's the halfway point? 1.5 pi, which would be right here. That will be a 0 for sine because it goes maximum, 0, minimum. That's the halfway point. So we could do it this way as well. 1.5 pi is the same thing as 3 pi over 2. I'm going to write it that way. 3 pi over 2, 1. And so what happens in the middle of these two zeros? The sign go increase first or decrease? Increase. So in the very middle, which would be right here, it goes up to its maximum. How many units up does this need to go? 3. 1, 2, 3 from this point. There's its maximum. So what's in between 0 and 1.5 pi? Or how about this? What's 3 pi over 2 divided by 2? I'm trying to cut that in half. What's 3 pi over 2 divided by 2? This would be 3 pi divided by 4. And its maximum value is at 4. Okay, now on the minimum, I go 3 units down from the midline. I'm right here. What's 3 units down? -2. Very good. Now where would this one be?
So it would be like,
So you're adding we're adding 3 pi over 4. That's how far apart these all are. We're adding 3 pi over 4. I'm just going to do the math here. Okay, this time I'm taking 3 pi over 2. And I'm adding 3 pi over 4. I have to do the middle school, get a common denominator, multiply by 2 over here. Excuse me, I don't multiply by 2. That was wrong. What did I actually just multiply by? I multiplied by 1. It's just a funny looking one. So it's 6 pi over 4 plus 3 pi over 4. That gives me 9 pi over 4. That's the location of this one. 9 pi over 4, comma, -2. And now we connect our dots. As a wave. Just try to round it off as best you can. So if you take the period and divide by 4, that's the distance between key points for sine and cosine. Sine and cosine 3 pi, you take the period and divide that by 4, that can find your key points. If you want to do a formula, that formula will always work for you. Okay, you see me roll through this now 3 times? I'll let you try one on your own here. Dual number 1. Let's move on. Example 2. So now I'm going to show you what some equations that are in general form. Here's a general form. Go ahead and write this down here. The general form is this. They'll use capital letters. A sine bx plus c plus d. Now what's different? Whoops, meant to do capital D. On the general form, when they give you this, the b value is not factored. Now this was the note that's earlier. So b is not factored. B is not factored. So what's the main difference between the standard form we've been working with and this one? Is that because b is not factored, c itself, this capital C, to get the lowercase c, c would equal the negative of capital C divided by capital B. That's what we're gonna have to do here. Notice that they'll use a positive in the equation, and that's a capital letter, not a lowercase c. So I'm just gonna show you on the problem. Okay, notice on this problem here. Is the 2 factored out? Do you see how? Let's look back at it. What problem? It's not on your DOL. How about this one? No. How about B? Do you see how the 1/2 is factored out and we have that square bracket? Okay, now go to our problem example 2. Is that 2 factored out? No. Okay, let's work our way through it. What would you say the amplitude is? 1.5. Because A is negative 1.5, our amplitude is positive 1.5. Okay, the period. What is our B value? 2. So we're going to take 2 pi and divide that by, 2 pi divided by 2. What's 2 pi divided by 2? Pi. That's because B is 2 there. Okay, phase shift. And here's what's different. So normally we would just say, oh, that's going to be left
3 pi.
3 pi, but you have to solve the argument. The argument's the inside. So it's actually going to be left 3 pi over 2 units. And that's because you would solve this for x. That's really what you do, is you solve it for x. Solve for x equals 0, I should say. And so the argument equals 0. What would you do first with that 3 pi over 2?
1.
And so it becomes negative 3 pi. And then how do you get rid of this 2? Divide by 2. That's why it's left 3 pi over 2. It's you take the argument and you set the argument equal to 0. That's how the phase shift works when it's not in factored form. Finally, the midline. What's our midline going to be? That's because D is negative 1/2. Okay, so now let's go graph this. Negative 1/2 is going to be right there. That's our midline. Let's add our midline on. There's negative 1/2. Cosine, does it usually have a y-intercept at its midline or its maximum? Maximum. Okay, this has negative on the front, which means this cosine will begin at its minimum. Not its maximum, but its minimum, because this negative. So I'm going to go down 1.5. Okay, now which way do I go? Left. 3 pi over 2. This is its first point. We'll say right there. Oh, I only went down 1, not down 1.5. There we go. Okay. So that's down 1.5. And left 3 pi over 2. Whoops, I forgot to put the value. Comma, -2. Okay, now, how long of a period does this have? Pi. So pi, if you want to look at here, pi would be from -3 pi over 2 to negative pi over 2. If you're wondering on that distance, you can check from the origin to pi. It's this amount of distance. You could count the blocks. How many little tick marks do you have to get from here to 1 pi? 4. Come over here. We're going 4 blocks. 1, 2, 3, 4. That will be one whole period, which is negative pi over 2 comma -2. Okay, let's fill in the points in between. Now this is nice. How many blocks do I have open in between these 2 points? 3, which is how many key points I have. So it's perfect. I go from a minimum to its 0, and from its 0 to its maximum 1.5 up. And from its maximum back to its 0. And from its 0 to the minimum. And then we'll repeat. This will be 0, maximum, 0, minimum. 0, maximum, 0, minimum, all the way down. 0, maximum, and so on. And so we can connect these points, and this would be a 0 over here. Just round it off as best you can. One more way from earlier in this lesson, if you're like, wait, how do I know how far to space apart these key points? Remember what you can always do is you can take that period and you divide it by 4. So you take your period and you divide it by 4 if you want to know how far to space apart the key points. I should say horizontal distance between key points. So you put horizontal distance between the key points. Okay. Questions on that? All right, let me do it one more time so you get to see the argument factored out again. When I say argument, what am I referring to? The inside. All right, let's do this again here. Oh, sorry. It says before we move on, let's describe the transformations. All right, so let's go one at a time. The transformations. When you have a negative in the front, do I multiply the y's by negative or the x's by negative here? Y's. That would be a vertical. Whoops, that's not how you spell vertical. A vertical reflection. And because we need to know this well, when you vertically reflect, basically that means you're reflecting your y values from a positive y to a negative y. Which axis do you actually cross over?
The x.
Okay, good. So we're vertical reflection across the x-axis. Okay, secondly, what about this 1.5?
That is a vertical dilation.
Very good. We're multiplying y values. A vertical dilation. By factor is what you'd say. That means to multiply. Okay, and now we're getting to the inside. What about this b value? A horizontal dilation. Now, did we actually multiply by 2? So dividing by 2 is the same thing as multiplying by 1/2. Okay, plus 3 pi over 2. We're going to divide that by 2 as well, but what type of transformation is the C? Horizontal translation. And it was not just 3 pi over 2. I mean, not 3 pi, it's 3 pi over 2 units. Which way? It shows positive, so we go opposite, which means left. Finally, the negative 1/2. Is that inside or outside? So that's a vertical. Vertical what? And then it's a liar or true teller. So negative means down vertically. So there's our 5 different transformations that took part in this problem. All right. So your second DOL. I want you to work through this. Now be careful. I'll sit back. Be careful. The B. Is the B factored? Yes or no?
No.
No. So don't forget you'll have to do take care of that B on your C value as well. So as you work through your amplitude, your period, that's like normal. Your phase shift is where things change. Your phase shift, you're gonna have to take into account that 3 has not been factored out. Okay, DOL number 2. Now to complete part A, then go on and complete part B of DOL number 2. All right, let's look at example 3 now. It says determine the same values that we've been finding. So example 3 is just kind of a repeat one last time to look at it. So let's start here. For amplitude, what we say the amplitude is? It's positive, even though, even though the A is negative 2? Yes. The amplitude is the absolute value of A, so that's still 2. Okay, what about the period? Well, this one's going to be different. It's 2 pi divided by what value? Pi over 3, which is the same thing. If you're dividing by a fraction, it's the same thing as multiplying by its reciprocal. So it's 2 pi over times 3 over pi. What's 2 pi times 3? 6 pi. But then you divide it by pi. 6. So the period is 6. Okay, phase shift. What's our phase shift? And all this is because B was pi divided by 3. No phase shift. Why none? C equals 0. Okay, what about the midline? Just 3? There you go. Y equals 3. And that's because the D value is 3. So we go up to 3. We put our midline on there. There's our midline. This is a cosine function. This cosine usually, quote, begin at its maximum, its minimum, or 0. It's normally at its maximum. What does this negative do? Minimum. So we're going to begin at its minimum. So the amplitude is 2, so I'm going to go 2 units down. Now, do I have a shift? No. So there's its minimum. Now, how long before we repeat? 6. All right. So now how many key points are there missing that I haven't graphed yet? If I have a minimum and a minimum, how many key points are there going to be between?
2 zeros and a maximum.
2 zeros and a maximum. Good. There's missing 3. How many blocks apart are these?
1, 2, 3, 6.
6. So if you think about it, the halfway point between 0 and 6 is 3. That will be its maximum. This will be easy. Go 3. Our amplitude is 2, so I go 2 up, 3 over, and 2 up. Well, I guess 2 up here, 2 more up. Okay. Its zeros would be in between. What's in between 0 and 3? 1.5. So at 1.5, we should have a 0 there. 3 plus 1.5 is 4.5. Those are our key values. And we could go ahead and plot these out the rest of the way. So every 1.5, you have another key point. 1.5, another key point. 1.5, another key point. And so on. Now we'll connect those dots. Again, try to curve it as best you can. Try not to draw straight lines. And there's our cosine curve. One more time. If you wanted to, by formula, to know what's the distance between a key point, what could I do to find a distance between a key point?
Period.
You take your period and you divide it by how much? 4. This is the horizontal distance. Distance between key points. You can always do it that way. Which that would be equal to that 1.5 is what we were getting earlier. 6 divided by 4 is 3/2, which is 1.5. All right, part B. So that from that same equation, let's list out the transformations. What do we do with that negative?
A vertical.
You're after. Okay, go ahead. That is a vertical reflection. Hey, vertical reflection across the x-axis. That's right. So vertical reflection across the x-axis. What does multiplying by 2 on the outside do? Vertical dilation. Okay, I'm multiplying by pi over 3 on the inside. Is that going to be a vertical or horizontal? This is now horizontal dilation because you're multiplying. But do I actually multiply by pi divided by 3?
No, you divide by 0. Okay.
Multiply by 3. Divide by pi by the reciprocal. Finally, the plus 3. What is that? Vertical translation. Very good. Up 3 units. And that's because it's a truth teller. So it's up 3 units being a positive 3. Right. Right here. Those are the see. All right. Example 3. Rather than doing another DOL, we're just gonna, excuse me, example 4. We're gonna jump right in and we're talking about writing equations. So this time we're gonna be given these values and plug in the equation. So first, if it says its amplitude is 3, that's our A value. Okay, so here it doesn't tell us if it's gonna hit its maximum or minimum first. So we're just gonna assume that A is positive 3. Let's just assume that. What would we say if the period's 2 pi over 3? What would we say the A? I'm sorry. Let me write it like this. What would we say the B value is?
3.
Good. 3 is 3. If it goes 2 pi over 3 to the right, that means C is. If it goes right, is C actually a positive or negative value? Yeah, we're gonna put this in as negative 2 pi over 3. And the midline is 0, which means the D value is 0. Let's write this as equation. We would say y equals
3
sine. Okay, now you have a bracket first. If you're writing this in standard form, which is the easier way of writing an equation. Put a bracket, there's your B, then do a parenthesis. X minus 2 pi over 3. Close your parentheses, close your bracket. Do I need to do a plus 0?
No.
No, that's your equation right there. Whoops. Y'all seem ready for that one. You want to try this one? Amplitude, tell me about that.
5.
What?
A.
A. A is 5, okay. Period.
0.5.
So that is 2 pi divided by b equals this.
0.5.
So 4 pi, all right, let's see if it's agree. If I did cross multiply and divide, I would have 4 pi b equals 2 pi. Oh, I agree with them. When you divide by 4 pi, I cross multiply, now I'm dividing. The pi's cancel out, that becomes 1/2. So b is 1/2, yep, b equals 1/2. Nice, phase shift.
Positive pi over 4.
I'll do a plus right there so we know it is positive. And finally, midline.
D equals.
D equals -2. So let's write our equation. It's a cosine. Y equals 5 cosine. Now do a bracket if you're writing it this way. Our B is, what was our B? 1/2. Parentheses. Not x minus, x plus pi over 4. Close your parentheses, close your bracket. -2. And your third DOL, I want you to write a sinusoidal function with a period of pi, passes through the point 2, 0, and has a maximum range value. What does it mean by range?
So like from the maximum the biggest height is 4.5.
That's telling you the greatest y value. The greatest y value of 4.5. Okay, so everything you need is in there. I don't use the term phase shift. It's in there though. Hint, hint. It's in there. Amplitude's in there. Phase shift is in there. I don't tell you midline, so just assume the midline is at 0. Maybe I should just say, which is on the midline. This on the midline. That way, passes to that point, which happens to be on the midline. And that'll give you everything you need. DOL number 3. All right, finally, example 5. It says graph the equation, or excuse me, find the equation of the graph, state the amplitude, period, phase shift, and midline. Well, I'm going to go in different order. I'm going to first start with midline. Midline is the maximum plus the minimum divided by 2. So 5 plus 1 is 6 divided by 2 is 3. I should have a midline at y equals 3 here, which it looks like I do. So the midline is y equals 3. That means my D is going to be 3. The amplitude is the number of units from the maximum to the midline, which I can tell here is 2. So my amplitude is 2. And my A, before I say it's positive 2, I'm going to look from the start and notice this graph goes down first. So this is going to be -2. Approaches its minimum before it approaches the maximum. Finally, for phase shift, I see this starts at the origin, so I want to say none. C equals 0. The period would be to here. The period is 4 pi, which we just saw that a second ago. If I took 4 pi and set that equal to 2 pi over b, we would get 1/2, just like the previous problem. Now I could write my equation that y equals -2. This is a sine. There is no c, so I don't have to have the brackets. I could just say 4 pi x plus 3, and that would be my equation. And I knew it was a sine because of starting here. This is a sine function. All right. With that, you can wrap up with your last DOL.